All right, everybody, so we are going to be talking about sine, cosine, and tangent today. And that's what these three things mean. You've seen these buttons on your calculators forever. All right, so sine, cos, tan. So what these buttons are is that each of these acute angles on a right triangle has these three trig ratios, or trigonometric. We just say trig for short. All right, now this is sine, cosine, and tangent. And we're going to be using this triangle here. We're going to be using angle A, so I'm going to label this triangle and all of its sides. The first things first, we're going to label our hypotenuse, which is across from our right angle. Then we've got this side, which is opposite angle A. That leg is opposite angle A. And then we've got AB, which is the leg adjacent angle A. The sine of angle A would be the leg opposite angle A over the hypotenuse. So the leg opposite of angle A is BC and the hypotenuse is AC. This ratio can tell me what the angle is or the side is, and we'll talk about why each of these things are there to begin with. All right, so just remember, sine is opposite over hypotenuse for any acute angle. The cosine of angle A is going to be the leg adjacent angle A over the hypotenuse. So in this case, we're going to be AB over AC. And for anything, your cosine is going to be your adjacent leg over the hypotenuse. This ratio only works for the acute angles. The tangent of angle A is going to be the leg opposite angle A over the leg adjacent angle A. So it's going to be BC over AB. And tangent, that means, is going to be opposite over adjacent. Something that we use and somebody's always used is Sohcahtoa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I do want to note that tangent, by the way, can be found if you've got the sine and cosine by just dividing those two. All right, so before we do anything, we're going to use this as our pre-example. I know I have it as number 1. I want you to write pre-example for this. And we're going to find the sine, cosine, and tangent of both angle A and of angle C. So let's start off with angle A. So for angle A, BC is my opposite, AB is my adjacent, and AC is my hypotenuse. Remember Sohcahtoa. Sine is opposite over hypotenuse, so it's going to be 5 over 12. Or sorry, 13. Cosine is going to be 12 over 13 because it's your adjacent over your hypotenuse. Now, these are ratios. These ratios are going to help you find missing sides and missing angles. All right, your tangent is going to be your opposite over your adjacent, so it's going to be 5 over 12. And then that's it. Now we're going to do the same thing, and I want you to pause your screen, pause your video, and try it with angle C. Set up your sine, your cosine, and your tangent. All right, so your sine for this is going to be 12 over 13, your opposite over your hypotenuse, and your cosine is going to be your adjacent over your hypotenuse. So you'll notice that your opposite and your adjacent change for each angle. Your tangent is going to be 5. I'm sorry, it's going to be 12 over 5. All right, now technically if you wanted to just find tangent for either one of these, let's do tangent of angle A. We could have just done it with sine over cosine. So we would have done 5 over 13 divided by 12 over 13, which is really just 5 over 13 times 13 over 12. These one out, and you get 5 over 12. This is a lot of math, but you'll need this later in your math career. All right, so why am I doing all these things? If you are only given, for example, one side or just the angle, then you can't use Pythagorean theorem to figure these out. If you are not given a special right triangle, you can't figure out those side lengths. So what we would have to do is we would set up our trig ratio. In this case, we've been given the opposite and the hypotenuse, which means I'm going to be using sine, which is your opposite over your hypotenuse. Now your sine of 28, and that's your degree measure right here, or theta, is going to equal x over 19. Now, when you're typing this into your calculator, please make sure your calculator is in degree mode. You can check that by clicking mode. It's going to look like DEG. Now, in order to solve for x, we're going to have to multiply both sides by 19. So we get 19 sine of 28. And that's going to equal x. If you have your TI-84 or any other graphing calculator, you can just type it in, but you must make sure it's in degree mode. So, if you go in to your calculator, because I have it off, you can actually type it in. And you should get approximately 8.9. Typically, you're going to have to round to like the nearest tenth or the nearest hundred. I will let you know. All right? So, make sure it's in degree mode. If it's in radians mode, which is what your calculator is typically in, you will not get 8.9. So make sure it's not in rad, but it's in degree mode. We'll talk about radians in a couple of chapters. All right, so let's do number 3. This one is working with the opposite in my hypotenuse, which means I'm working with sine again. So sine of theta, which is your angle, your degree, opposite over your hypotenuse. So the sine of 33 is equal to 15 divided by the length of my hypotenuse. In this case, that's x. When I'm presented with something like this, I just make this into a fraction and then cross multiply like we'd been doing. And I get x times sine of 33 is equal to 15. In some calculators, by the way, you are going to have to write that parentheses, and in some you don't need to. It automatically will prompt you. All right, so we're not done solving for x yet, so we have to divide both sides by 33. This one's out. And you have to remember that sine 33 is some number. It's an irrational number, but it's a number. Kind of like pi, or the square root of 2, or the square root of 3. We don't like writing 2.7214 whatever for square root of 2. We just write the square root of 2. So sine 33 is just some number. All right, so what we're going to do is we are going to plug this into our calculator, and we're going to do 15 divided by the sine of 33. And when you type in 15 of sine 33, 15 over sine 33, you get x is approximately 27.5, meaning this hypotenuse is almost 27.5. Now that was for finding missing sides. You can also figure out what the missing angle is if you just have two sides. Now, if you know the sine, cosine, or tangent ratio of an angle, then you can use the inverse function, and that's sine inverse, cosine inverse, tangent inverse, to find the measure of the angle. All right? Now, when you find the measure of the angle, what you're going to end up doing is you're going to use that inverse button. If you're on your TI 84, that's going to be second, and then the trig function that you need, so sine, cosine, tangent, whichever. All right? For some of you, if you're using your scientific calculator on like your iPhone or your Android, then it might not be written that way, and it might be written as arc sine. And arc sine is still the inverse of that. So the way that we're going to do it is that we're going to set up our ratio. And for this one, we'll notice that my hypotenuse is right here because it's across the right angle. And I've been given the leg adjacent to angle X. So what we're going to do is that I'm going to go ahead and set up my ratio for cosine. So the cosine of X is equal to 8 over 11 because it's Sohcahtoa. Now, that gives me nothing, but what you can do is you can do cosine inverse of 8 over 11, and that gives you X. Pretty much you end up switching these out. So when you plug that into your calculator, make sure you're in degree mode again. Then you're going to get X is approximately 43.3. And we don't need to write the degree since the degree symbol was already on here. So it's going to be X is approximately 43.3. All right, let's try the next one. So this one we've been given the opposite over my hypotenuse, which means we're going to be using sine of X because that's so, opposite over hypotenuse, 40 over 41. So then we're going to do sine inverse of 40 over 41 to get X. Make sure that calculator is in degree mode. And you should get that X is approximately 77.3. If that degree symbol wasn't there, then we would put it on our X. But in this case, it is, so we don't have to worry about it. All right, last one. And in this one, we've been given the leg opposite and the leg adjacent, right next to. So we're working with opposite over adjacent, which means we're working with tangent, which is Sohcahtoa, and we're going to set up tangent of X is going to be our opposite of 7 over the adjacent of 5. Take the inverse so you can swap it. and that's going to get you x. So when you plug it into your calculator, you get approximately 54.5. All right, and that's what sine, cosine, and tangent are. Some people like to use Sohcahtoa. I'm one of those people. Some people also like to use each of these triangles, and they're kind of like that negative times a negative and positive triangle. But this one is your division sign, and this one is your x. You're multiplying. So this is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over my adjacent. So it's just a matter of what you've been given, and you can use these triangles. Some people like them. I haven't seen many that do, but it's there for you if you'd like it. Thanks for watching.